I'm Anil Kumar. Welcome to my series on trigonometry. Here we have a question from one of our subscribers. Let me thank all the viewers and subscribers for watching these videos and sharing their views. The question here is, on a certain island, the population of rodents vary according to the season. This can be modeled by the function r of t equals to 10,000 plus 5,000 cos pi t over 6, where t is time in months and rt is the estimated rodent population after t months. Note that in this model, t equals to 0 corresponds to month of January. What time interval does the period corresponds to? B is, what effect does the seasonal variation have on the rodent population? And C is, with reference to the first year, in what months will the rodent population reach 12,500? You can always pause the video and answer this question. Here is how I will solve it. So we are given rodents population R of t as equal to 10,000 plus 5,000 cos of pi, let me write like this, pi by 60, right? So that is the population. We need to find the time interval. Now, time interval can be found from pi by 6. So time interval t is one full circle is 2 pi divided by this value of k, which is pi by 6. Correct. So you could also write this as 2 pi times pi by 6, right? Now, cancelling pi and multiplying 2 by 6, we get our time period as 12. So here it means 12 months is the time period. That means one full year, right? So what interval does the time period corresponds to? So it corresponds to 12 months, right? So that is part A for us. Now let's see how to do part B. What effect does the seasonal variation have on the rodent population? So for that, I like to sketch the function itself. So from there we can discuss it. So let's say, let me draw it here. Okay. So let's say this is our time, right? And here we have the rodent population R of t. Since we are given that 10,000 is the axis, okay, so that is 10,000. We are working on a cosine function, cos of this, which goes up by 5,000 and down by 5,000 depending on cos value, which could be positive 1 or negative 1 at the extremes, right? So, and it begins with the maximum value. So we could draw this as kind of like this. Let me just sketch this first and then we can discuss. So this is one way, right? So it kind of continues. Okay. Now in this particular wave, which I have sketched for you, that 0 starts with 1st of January, okay, and it ends here with 31st of December, right? So that is one full year. These are the 12 months, okay. Now it says, what effect does the seasonal variation have on the rodents population? Well, as far as the seasons are concerned, what we know is that the January comes basically in winter. So let's talk about seasons in, so we say this is winter, right? So somewhere here, okay. So these 4 periods here can describe you the seasons, right? So here we have spring, this could be summer, and then autumn, and then winter, right? So let's call this winter. Okay, so which starts kind of here, right? So not exactly, but approximately. So that is how you could see the seasons, right? So we'll take North America as an example and 4 seasons. Okay, so what effect does seasons variation have on the rodents population? So we can say that it is maximum during the winter season, right? So we can say maximum in winter, right? It actually declines during spring. And then increases from summer. Right? So this could be treated as peak summer, right? So after that, it kind of increases and, it's pretty high. Highest level is reached in winter. So that is your seasonal variation. Is that clear to you? Perfect. Now let's answer part C. With reference to the first year, in what months will the rodent population reach 12,500? Let me do it on a fresh page, right? On this page, let me write down the values. This is 10,000. This is 15,000, right? 5,000 more, and that becomes 5,000. Okay. Now let's take part C on a fresh page. In part C, we want to find in what months will the rodent population reach 12,500, right? So let's rewrite the equation, which is rodent population is 10,000 plus 5,000 cos of pi by 60, right? As we had sketched last time, let me again sketch it right here. It helps to understand the situation. We are saying 10,000 is kind of the average population. It is maximum in the winter, dips down and picks up in summer, right? So that's how it is. When we say that we want to find when it reaches 12,500, so 12,500 will be this line. So we are interested in finding 2 points. First this point and then this point, right? So these are the 2 points which we are interested in finding where the rodent population will reach 12,500, right? So this value here is 15,000, right? This value here is 10,000, and the minimum is 5,000. We are interested in finding when will it reach 12,500. Okay? So let us see how to solve trigonometric equation. So this rodent population, we want this to be 12,500 equals to 10,000 plus 5,000 cos of pi by 60. So taking away 1,000, we can write this as 12,500 minus 10,000 equals to 5,000 cos of pi by 60. So which is 2,500, right? So when we take it away, so we get 2,500. So now we can actually I'll do let me do it in 2 steps. 5,000 cos of pi by 60, right? Dividing by 5,000, what do we get? Which is half, right? We get this as equal to cos of pi by 60, right? Now, where is cos theta? When is cos theta equals to half? This is what you need to figure out, right? You could use special triangles for this. Okay, so let me make one here. So you remember the pi by 6, pi by 3 triangle, right? So in this triangle, the sides are 1, 2, and square root 3. So for cos of pi by 3, we get the value half. So we know cos pi by 3 equals to half, correct? So we have this equation as cos of pi by 6t. So that basically means that pi by 3 should be equals to pi by 6t, right? Correct? So we'll solve this equation. So what we get from here is, let me take it here now on this side. So what we get here is that pi by 3 equals to pi by 6t. And then cross multiply 6 by pi times pi by 3 equals to t. And simplifying, we get t equals to 2, right? So pi and pi cancel, and we get 6 equals to 2. So that is one answer, right? Pi by 3. But we are looking for the second one also. How do we get that one? Well, let's try to understand the situation. Cos is positive for two quadrants, quadrant 1 and quadrant 4, correct? So that was the real question. How do I get this value, right? And we figure out that this is pi by 3. So it has to be minus pi by 3. Do you see that? Or you could say the principal angle here is 5 pi by 3. Does it make sense to you? So we also know that cos of 5 pi by 3 is equal to half, right? So that should also be equal to cos of pi by 6t. And that gives you the second answer. And so the second answer for us is, so equating this here, let's go like this now. So we have pi by 6t equals to 5 pi by 3, correct? And that gives you the value of t as pi and pi cancels, that goes 2 times. So t equals to 5 times 6 over 3, which is 10. So at t equals to 10 also, that will be the value. Is that clear to you? Right. So this value here is at t equals to 2. And this value here is at t equals to 10. Got it? So that means this is kind of 1st of March, right? So that is March for you, right? So then we say when it reaches 12:50 is right at the beginning of March, 1st March, or you can say this is, do we want month, right? What months, right? So this month is March, correct? And adding 10, what do we get? So we get October, right? So that month will be October. So when you add, actually, because this is 0 is January, right? So 2 is becoming March. So 10 will be November. So because we are looking into the 1st of November in this case, right? So it will be November. So 2 correspond January, February, March, means the 3rd month. So 10 will correspond to 1st of November, right? So this reading from here gives us 1st of November. This seems to be 1st of March. You get the idea, right? So that is how we are going to answer this question, and that becomes our answer. So I hope the solution is absolutely clear. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.